Hello everyone, my name is Alekia from MSc Computer Science. Today I am presenting the seminar on transport layer security. On this topic we are going to discuss introduction of TLS, what is TLS, what does TLS do, TLS protocol stack, TLS record protocol, TLS handshake protocol, chain cipher spec protocol and alert protocol. Introduction of TLS. TLS was proposed by the Internet Engineering Task Force. It is an international standard organization. And TLS was derived from Secure Socket Layer, which is the previous version of TLS. The first version of TLS was published in 1999 and the recent version is TLS 1.3, which was published in 2018. What is transport layer security? Transport layer security is designed to provide security at transport layer and is used to create a secure connection between a client and a server so that no third party can access the data. Here TLS provides secure connection between two entities. What does TLS do? TLS ensures encryption, authentication and integrity. Encryption hides the data being transferred from third parties, which means converting the plain text to ciphertext. Authentication. Authentication ensures that the entities exchanging information are the authorized one or not. And the last one is integrity. Integrity verifies that the data has not been changed or tampered with. TLS protocol stack. This is the architecture of transport layer security, which involves several components and the processes that work together to establish a secure connection between client and a server. Handshake protocol, chain cipher spec protocol, alert protocol, TLS record protocol. Now we'll discuss about the TLS record protocol. TLS record protocol provides two services to TLS connection. One is confidentiality and the other one is integrity. Here this is the application data. The data is divided into fragments. Each fragment is compressed by using some compression methods. This compression is lossless compression, which means data loss will not happen. At the same time, the size of the data will be compressed. After compression, the encrypted MAC generated by algorithms is appended to the data. After that, encryption of data is done and in last, TLS header is appended to the data. TLS handshake protocol. This protocol allows the client and the server to authenticate by sending a series of messages to each other. This protocol uses 4 phases to complete its cycle. Here this is the process how a client and a server uses the handshake protocol to negotiate how to exchange the data. In phase 1, the client initiates the TLS handshake by sending client hello message. This message includes information about the TLS version supported by client and a list of cipher suits and compression methods. Here the cipher suits are nothing but a set of encryption or cryptographic algorithms. After that, server responds with a server hello message that contains the encryption algorithms chosen by the server from the list provided by the client. After that, in phase 2, server sends its digital certificate to the client to authenticate itself to this client. This certificate includes the server's public key. After that, server requests client certificate and server signals end of hello message in this phase. In phase 3, client replies to the server by sending client certificate and client exchange key. Client may send certificate verification. In phase 4, chain cipher suit occurs, and after this, the handshake protocol ends. Once the handshake protocol is done, the server and client can now exchange messages that are encrypted with shared secret key. And the next protocol is chain cipher spec protocol. This protocol consists of a single message which is 1 byte in length and can have only one value. This protocol purpose is to cause the pending state to be copied into the current state. Alert protocol. Alert protocol is used to convey TLS related alerts to the peer entities. In this, each message contains 2 bytes. One is level that contains 1 byte and the other one is alert that contains 1 byte. In first byte, it has 2 levels. Level 1 is warning alert. This alert has no impact on the connection between sender and receiver, which means this alert does not affect the connection between a client and a server. Example, certificate expired and no certificate. And level 2. Level 2 is fatal error. This alert breaks the connection between sender and receiver, which is immediately terminate the connection between a client and a server. Example, bad record MAC and handshake failure. And the second byte in this protocol describes about the error. Thank you.